Hello everybody, this is Greg from ChemCore. In this video, we're going to be discussing the worksheet from the Hydrocarbons Revisited video. Now, this kind of video was maybe just a reminder of some stuff that we discussed in the past. I know some of you may not have stuck with me since Unit 2 or Unit 3 or Unit 1, and so this is a really great way to catch up on things I might have mentioned before. And all this video was mainly trying to do was, hey, let's remember all of the ways I taught you guys how to remember naming straight chain and really simple hydrocarbons. Because from this we start developing, especially naming hydrocarbons and naming any molecule, we really start understanding with these fundamental concepts. And I usually during an explainer video, I start with kind of summarizing some important things we said in the video. But the first question, that little chart that you'll see in your worksheet, will be the perfect summary for our purposes. Now, just a reminder, if you guys haven't been able to see this worksheet, go check in the description below. It is in the links provided, and the answer key will also be provided there. Okay, let's get started. Complete the following table, either filling in the number of carbons, formula, or IUPAC name for simple hydrocarbons. So for one carbon, we know that the formula is, or the name is methane. Okay, and for ethane, we know we have two carbons, which means that, well, let's try this out. So if we have two carbons, we want to fill in the rest. Notice that we'll now have six carbons, six hydrogens. And so the formula will be C2H6. And now a common question that is a valid question is, well, why is methane CH4? And as we bring up carbons, we don't double the number of hydrogens directly. We're kind of losing one, right? If you were to think like that, you should end up with 8 hydrogens, but you actually end up with 6. Why? Well, because the bond between the carbons actually takes away from a bond that hydrogen could have. And so I really want you to be careful and remember that for alkanes, or for simple straight chain hydrocarbons, the formula for the number of hydrogens is 2 times the number of carbons plus 2. So that's a really, really easy way to remember how many hydrogens you have, and you don't have to draw it out, okay? And so the next molecule, or the next part that we have to fill in, is propane. And so it's kind of obvious from the formula that we have 3 carbon atoms. And then the last of this kind of group, and we'll talk about what this group is butane. Okay, and so following our formula, if we have C4, well, C4, 4 times 2 is 8, and then minus 2 will become 6. And so why do I call this a group? Well, because these 4 names, these first four hydrocarbons, methane, ethane, propane, and butane, aren't named like the rest of the molecules you'll see from now on, right? Or with number of carbons greater than 4. And that's because they're named according kind of to Latin names for the numbers. For example, a shape with 5 sides is a pentagon, and a molecule with 5 carbons is pentane. But before that, methane, ethane, propane, and butane don't really come from those names. And so I like the mnemonic my excellent protein bars. Let's kind of remember that. So my stands for methane. I'll just write meth for short. Excellent stands for ethane, eth for short. Protein stands for propane. And bars stands for bute, or butane. Okay, and so that's a really easy way to remember what your prefixes are. Okay, you might have noticed really quickly I had to move my face cam on the video, so I might have shifted a little bit, but let's keep going. Pentane will now have 5 carbons, and so using our formula, we'll know we have C5, and 5 times 2 is 10, minus 2 is 8. And so the formula for pentane will be C5H8. And so for this formula, we have 6 carbons. And so remember that for 6 carbons, our name is hexane. Right? Just using Latin prefixes that you hopefully are familiar with from grade school, right? With learning shapes. For 7 carbons, heptane will have C7. You multiply that by 2, you'll get 14. And then subtract 2, you'll get 12. And then the next molecule, 8 carbons, is going to be octane, like an octagon, right? Nonane has 9 carbons, and so we'll call that 9. Kind of an easy name to remember when it comes to 9. And 10 will have the formula of C10 times 2 is 20, minus 2 is 18, and our name will be decane. So that previous chart was just being able to connect the number of carbons and then the formula and then to the actual name. But now I kind of want to go over, okay, how do these structures look? We're more than familiar with bond line structures. Can we connect bond line structures to our actual concepts of simple straight chain carbons? And so really what you just have to do is you have to find out how many carbons we have and then use your rules of naming and your name prefixes to give these alkanes a name. And then all you have to do, the second part of the problem, is to practice some conformational isomers. I like to throw in a little task or two in there. And you just have to draw any molecule that has the same formula but looks slightly different. So for the purposes of this video in the answer key, I'll be using just one example of a conformational isomer, although be aware that there's many, for a lot of these, there's many different conformational isomers that you can draw. And also we'll be identifying each of the carbons that we circle as primary, secondary, tertiary, quaternary, although we shouldn't have any tertiary quaternary. And so for our first example, here are the carbons, those pointy ends. So we'll circle all of them. And notice that the ones at the end, right, this one and this one are both primary carbons because they're only connected to one other carbon. And then all the carbons in the middle are only connected to secondary carbons. And so these are all going to be secondary. And so I count 5 carbons. I don't know about you, but I count 5 carbons. And so the name of my molecule should be pentane. And so to draw a conformational isomer, a really easy trick I like to do if you're ever tasked in one of your classes or your organic chemistry course to draw a conformational isomer for an alkane, a really easy way is to just, let's take one of these lines and just put them somewhere else. Okay? So for example, if we were to keep these 4, right? So these 4 carbons, like that, and then just let's switch the last carbon and put it on somebody else. And so we'll put it on this guy, right over here. And so that way, think about it, we end up with 5 carbons and it definitely looks different. And so you might be tempted to count the number of hydrogens that you'll have, but you actually don't need to, because remember, it's still an alkane, right? An alkane is an alkane, the formula should be the same, and conformational isomers, the definition is the formula is the same. So no matter how you really mess with the molecule, your number of carbons and hydrogens should remain the same. But I guess it's a good way to check if you're not sure. The next molecule will have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so notice that 9 carbons, the name of our molecule will be nonane. Oops. Nonane. Okay. And the first carbons, all the way at the beginning and the end, are going to be our primary carbons. And I actually couldn't draw all the way at the end. There's something wrong with my writing tablet, but I ended up having to use my mouse. And all of the remaining ones, from here to here, okay, from here to here, are going to be secondary carbons, okay? And so one really easy way is, well, let's draw 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, okay? And let's just put an extra carbon right over here. And that ends up still being nonane because we still have 9 carbons, and the structure is very different. The next structure I count 1, 2, 3, 4, 5, 6, 7, 8 carbons. And so I know that the name of my 8 carbon molecule will be octane. These first ones are going to be primary. All of the ones in the middle are going to be secondary because they're connected to 2 carbons. And so one easy way to draw a conformational isomer is, well, let's draw 1, 2, 3, 4, 5, 6, 7 carbons, and let's put an extra carbon on anywhere along the chain except for the end, right? And so usually we would put it on either this carbon or this carbon, but just to show you guys that there's a lot of options, you can actually just put it right in the middle. The next molecule, I count 1, 2, 3, 4, 5, 6 carbons. And so this one is going to be primary. All of the ones in the middle are going to be secondary. And this one at the end will also be primary. And 6 carbons, 1, 2, 3, 4, 5, 6 carbons, corresponds to the name hexane. So one easy way to draw a conformational isomer is let's just draw 5 carbons and connect an extra carbon somewhere along the chain. Last 2 problems, I count 1, 2, 3, 4, 5, 6, and 7 carbons, and 7 carbons corresponds to the name heptane. Okay, and so this first carbon is going to be primary, this last carbon is going to be primary. All of the ones in the middle are connected to 2 different carbons, so they're secondary. And one easy way to draw a conformational isomer is let's draw 6 carbons. And so usually I'd put an extra carbon right over here, but realize I can also put it right over here. Still a conformational isomer. And the last problem, I count 1, 2, 3, 4, 5, 6, 7, 8, and then 9 and 10. And so these ones are going to be primary. And all the ones in the middle are going to be secondary, and that includes this one. Okay, it's just not letting me draw all the way. And so for 10 carbons, our name will be decane. Okay, and one easy way to draw a conformational isomer is let's draw 9 carbons. Okay, that should be 9 carbons. And then we'll just stick an extra carbon anywhere along the chain, and I just happen to choose this carbon. Okay. If you guys are unfamiliar with these concepts, go back to my informational video, it's linked in the description below, and go watch that. It's only a couple minutes long. I really think it'll help digest these concepts. Again, if you haven't had the chance to do this worksheet or see the answer key, also linked in the description below. It'll take you to my website where you'll be able to download this worksheet and the answer key, as well as every other worksheet and answer key that I've provided. And again, if you have any questions, drop them in the comments below. I'll try to get to them as soon as possible, and see you guys in the next video.